Hey, how's it going, everybody? I'd like to put together a little video today on a topic that's important for game development, especially if you're going to be coding your own games. That is the fixed time loop that is very important to the core of any game. We will go through the code here momentarily on how to create fixed time loops. But the important thing is that a fixed time loop lets you run your game with a fixed time interval, say 30 frames a second or 60 frames a second, so that the logic and physics and everything that you've programmed into your game to be consistent can run in a manner that is expected. Complementing this cycle of 60 frames a second is usually an outer loop, which can be used to run game rendering as fast as you can possibly do. So today we're going to code up a very basic fixed time loop in C and C++. And with it, hopefully you can use the concept if you're writing your own game engine to make sure that your games are running very smoothly. So with that being said, let's go ahead and get started coding. So we have our most fundamental element of a C or C++ program, which is the main. So let's talk a little bit about the fixed time concept here. So usually when a game is running, you have two main loops running. You have an update loop and you have a draw loop. The update loop is where things like physics run, polling for input from controllers or keyboards, and running all of your game logic around characters moving around on the screens, changing the frames of animations if you're doing 2D. All that runs inside of your update loop. The draw loop is where literally all the rendering back and forth to the GPU gets done. And so us as gamers, we like really high FPS games, but us as programmers want consistent. We want consistent physics, and we like to have things running at a very consistent frame rate under the hood. So the way games generally approach this is by separating it out into two types of loops: the update loop and the draw loop. The update loop will run at a fixed time interval, hence the name of the video. And the draw loop is just going to run as fast as it possibly can, so that it will be able to pump out as many frames per second to your screen as it possibly can. Before we can do that, though, let's go ahead and just build a couple data structures that we need, that we can utilize some parts of SDL from to actually track the amount of time that's gone on. Okay, so what we've done here is written a very important struct called timer. And the timer tracks the number of seconds that have elapsed since the last time we checked the timer. It does this by using two incredibly important functions from SDL. One called SDL get performance count, and the other one is get performance frequency, which is the number of cycles per second that this machine is capable of. Sorry, this get performance count is really how many cycles it has run since the game started. So with those two structures, we can actually take a timer and track how many seconds have passed from the last time we ran the timer. So we get the current ticks, which is how many how many CPU cycles have run. We get the difference between the current ticks and the previous ticks of our timer, and that's our delta. We update our previous ticks to the new current ticks, and then, given the frequency of our CPU, we can calculate how many seconds have run by taking the number of cycled ticks and dividing it over the ticks per second. This elapsed seconds is, as it says, the elapsed seconds since the timer was last checked. And with that, it's going to be incredibly important for us to use this to have fixed time loop intervals. So from here, I'm going to jump forward and I'm going to build out the rest of the while loop guts down here, which will implement this timer into fixed time intervals. Okay, I had to deal with a little bit of debugging there. I always forget to copy the DLL files into the output folder, which is why I couldn't get it to run. But given all that, we have these data structures now implemented, and we have 3 timers that our loop is actually going to be utilizing. We've got the system timer, the update timer, and the draw timer. Now immediately right off the bat, we're going to run tick on the system timer, which is going to initialize it to all the first values that it can find from our SDL functions. Then we're going to enter into our while loop, and there tick our system timer again. Now this is going to run on every loop now, which means it's going to be getting the number of seconds that have elapsed between every while loop, which is important. We have a variable here called accumulated seconds, which is basically adding up the total number of seconds that have passed in this while loop's loop. And then if that number of accumulated seconds is greater than our target frames per second, this is where our fixed time comes in place. We're going to run the inside of this if condition only if the while loop has run so many times it exceeds our FPS. So once we're inside of here, we're going to go ahead and decrement our accumulated seconds by the cycle time. So that way it's saying, hey, I actually have consumed some now. And then we're going to update, we're going to tick our update timer and then our draw timer. So with this, inside of this if function, any code we put in here is actually going to be fixed to the targeted frames per second, which is currently set at 60. Anything that's put down here outside of this if condition is going to be running as fast as the while loop can possibly do. So let's go ahead and code up a basic output for us to show this update and draw cycle running and how fast and how different they run. Okay, so what we've done is written 2 functions, one called update loop, one called draw loop, which is essentially what you'll have in your own game. Additionally, I'm passing in the specific timer's elapsed seconds as a parameter into these loops so that inside of your game code, whenever you get this delta seconds, you'll be able to say how many seconds has it been and use that to simulate specific physics and actually adjust for the variation in time that has passed on your actual machine. So it's very important, and right here is where you'd pass that delta time down into all the rest of your game. Inside the update loop, I have it just printing the word update and 2 new line breaks, and in the draw loop, we're just going to print the character D in a space. And given our concepts here, what we should see is that the draw runs many times and the update runs periodically. And this is at a target FPS of 60. So let's see if we can get this to work. I'm going to go ahead and say clear the screen before I output as well. And we can go ahead and run build. This is not supposed to be passed in by reference. These are floats. And let's see. Must be having to put in an and condition here in my build. Okay, now it is running like crazy. I'm sure it just looks like a huge blurry op, but I'm going to go ahead and stop it. And if we look at the output here, we can see the D character was printed, I don't know, several hundred times at least. And then the update cycle runs once. draw several hundred times, even a different number of times, and then update once. Draw, update, etc. And so this right here illustrates how many times the draw function is running in comparison to the update function. If we set up some timers here, you'd see the update function will be running roughly every 60 frames per second. And the draw function here is essentially running several hundred frames a second. And this is just in command line. So it's a little hard to visualize this, so I say what we do here is upgrade this to where it's not just printing characters all over the screen, but start printing out some animations. So I'm going to go ahead and code that up right now. Alright, so what do we coded up here? I've gone ahead and added what I call an animation, and essentially it is just an array of characters, starting with a bar, and then a slash, and then a dash, and then some pipes, and then a reverse backslash. And what that's going to do, hopefully, is show us on the command line this line essentially going and rotating. I have a couple additional support variables for that. I've got the animation index and animation max, which essentially are set here in the setup game function. And what they are going to do is track what frame and iterate across those characters inside of our animation array. Then I've got a function called print animation, which goes ahead and gets the animation character we want to print based on the current frame and the total number of frames, and then prints that out. Now I'm doing a /R in the print here because that means return to the beginning of the line. So we're going to output a character, return to the beginning of the line, output a character, return to the beginning of the line, etc. And that should actually have us overriding our own characters. I want to increment our animation index every frame, so we should see it cycle through our rotating line at the same speed that the loop is going to be running. We put it in the draw loop for now, and one more thing I got to do is just run setup game. And then if I build this, it'll be kind of hard to see, but it is absolutely running at a blur speed. You can see the little lines running there. So let's actually stop this, zoom back out here, and let's change it and put it in our update loop. Run it again. And it's outputting super fast again as well. It's rotating, it looks like a blur to you, I'm sure. But it's actually smoother to me. But we can actually change the rate at which this now rotates since it's in the update loop. And we can do that by going to our frames per second and saying, hey, instead of running at a target of 60, let's run at a target of 10. Now look at it. Much smoother. Let's go ahead and give ourselves a little spacing on it as well, so our little cursor's not right next to it. There it is. Nice, smooth. And if you've done command line work, you might actually see this kind of animation in some progress bars, etc. And so that is really nice. And we can see that at 10 frames a second, it's consistent, even though the draw was running incredibly quickly. So this has been pretty fun. I want to go actually one step further and see if we can't do just a command line animation. And so let me go ahead and update this, and we can see something doing something a little more interesting than just a bar spinning. And then we'll go ahead and continue on. Okay, so I've gone ahead and added an actual animation here. We'll call this our Fat Kirby. And what he's going to do is be sitting here looking away. Then he's going to look over and see an apple and then eat the apple. We've gone ahead and changed the animation from being an array of characters to an array of strings, character pointers. And then in our setup game, we've set our animation max to actually calculate off the size of a character pointer instead. And then when we print the animation, we're going to print out a string instead of a character. But essentially, it's the same concept. We're going to be running at 10 frames a second here still, and let's see what happens. I cannot convert from car to car, line 79. That should be fixable pretty easily. Yes, it's a string. And there we go. So over and over again, our actual animation will be running at a fixed 60 frames a second, having our fat Kirby going over it and eating an apple and munching it away. And just to illustrate that we can, if we were to switch this animation over to our draw loop, I mean, Kirby is really, really insatiable at this rate. Let's jump him back over here to our update loop. Let's make him eat a little faster though. Let's say he's just a little hungry. We're gonna switch to 20 FPS here, and we're gonna run the build. There he goes. So, very simplistic, and obviously you can see the entire code is running in one file. It's not a complex concept, and incredibly important for you if you're going to build your own game systems or game engines or whatnot. From here, I want to, go from here and talk about other algorithms like quad trees, shadow casting, other types of renderings, explore SDL a little bit more. But I thank you guys for watching, and I will link to the source code in the video description, and I'll see you guys later.